Alrighty, here we go. So this is the first question. It is on page 8, number 9 in the packet. It is, as you can see, how many moles of ammonium nitrate, which is that, are in 50 milliliters of 0.5 molarity solution. This is a simpler problem and requires no stoichiometry, thank God, but we'll be getting to one of those later. So remember that the formula for molarity is molarity equals number of moles over the number of liters. So since we have 50 milliliters, what we want to do is get our calculators out. Yes, I realize that I thought you could see other applications on my computer when I was recording. You cannot. This will be, I think this will happen one more time in the video, but I will try and fix that with later videos. And say 50.00 and 4 sig figs divided by 1,000, since there are 50 milliliter, or not 50, that's what we're working with, since there are 1,000 milliliters in a liter. And then we get 0.05, so liters equals 0.05. And we got to tack on 2 extra sig figs to make that 4. And then we go with, we have our 0.5000, so M equals 0.5000, and then we simply plug these two into our formula over here, which would give us 0.500, one more, O, equals the number of moles over the number of liters, which is 0.05. I'm not writing any more zeros. And then we just solve this like algebra. So multiply to get rid of u, and then scooch that one over. So you end up with 0.5 times 0.05, which ends up being times 0.5, nope, not times 5, times 0.5, which ends up being 0.025. Remember 4 sig figs, so we go 0.0250, and that is your answer for that. Pretty simple. Alrighty, the next question I'll be working on is number 1 on page number 11, and it's the first stoichiometry problem, and it says, what volume of 0.205 HClO4 solution is required to completely react with 50 milliliters of 0.0875 NaOH. And then what we want to do first is balance our equation. So we take the H, that's a terrible H, that's still pretty bad, HClO4 plus our NaOH, and get us to our product should be Na parentheses ClO4 plus H2O. There we go. We've got water, sodium perchlorate, and then we've got our two, whatever they're called. I don't remember. We've got our two things over here, and if we check, these all should balance up. There's 2 hydrogens over here, 2 hydrogens over here, and there's 1 hydrogen there, or 1 oxygen there, 1 oxygen there, 4 there, 4 there, so 5 on both sides, 1 sodium, 1 sodium, 1 chlorine, 1 chlorine. So this is just a 1, 1, 1, 1. Perfect. So now we write down our constants and our formulas. Our formulas are M equals molarity equals the number of moles over the number of liters. So what we're looking for is the volume for this, and we know it's molarity. So its molarity is 0.205, 0.205, and then we know this, its volume, is equal to 50 milliliters, and then its molarity is equal to 0.0875. Now, where do we go from here? First, we should solve for the number of moles of this. So then, since we know this is a 1-to-1, these number of moles will be the same. And we have everything right here necessary to solve for number of moles. So, take our formula. Let me get a different color. Take our formula over here of 0.0875 equals moles over liters, which is 50 milliliters is 0.05 liters, because remember, divide by 1,000. So we get 0.0875 times 0.05, which is what was that? 0.004375. 0.04375 equals moles. So that means little m equals 0.04375. That's a horrible 7. Let's fix that. 7.5. So now that we know this, we can now assume that this is the same. Since it's a 1-to-1, that means m equals 0.04375, which now we have everything over here that we need to solve for volume. So what we do is we take our molarity of and we'll get a new color. What do we feel like? Well, I feel like purple. So we'll do 0.205 equals, so we're taking all this and putting it here. So we get 0.205, which is our molarity, equals our moles, which is 0.04375, you get it, over our liters. And what we can do is multiply this over and then divide that over. So we end up with liters equals 0.04375 divided by 0.205. And if we plug that into our calculator, so divide U by 0.205, we end up getting our amount of liters equals 0.0213. We'll stop right there since we've got 3 sig figs in our starting equation. Those 3 right there, and then there is a 0.0 that I forgot to write in, but there is 3 here, and then these 3 right there. So 3 sig figs, we round to 0.0213 liters. That's kind of a small, messy number, so we'll go to milliliters. So our volume that is needed completely is 20, and remember, milliliters to liters is multiplied by 1,000. Yes, I know, I said multiply by 1,000 when you're going milliliters to liters. You're supposed to divide by 1,000. But we were going liters to milliliters, which is multiplying by 1,000, but I got the terms wrong. Just remember, milliliters to liters, divide by 1,000, liters to milliliters, multiply by 1,000. So multiply that by 1,000, you end up getting 21.3 milliliters for your answer. There you go. Alrighty, next one we're going after is not number 4. It's changed my mind. I'm not going to do that anymore. We are in fact going to do number 6 on page number 12, because I think this one was probably the hardest in the packet. So what we're going to do is we need, it says if 45.2 milliliters of barium chloride solution, barium chloride is BaCl2, barium chloride is needed to react with 0.222 grams sample of sodium sulfate, which is Na2. Yeah, because sulfate is, yeah, okay. Sorry, I was working this out. SO4. Now it wants us to solve for the molarity of the barium chlorate solution. And that is what we're going to do. So molarity equals question mark. We don't know. But over here, we're going to write out our formulas. Equals moles over liters. So what we want to do first is balance this equation, which we scroll up a little bit and give ourselves some more space. We go BaCl2 plus Na2S, oops, that's horrible, SO4, and then over to our products are going to be NaCl, which is table salt, plus barium sulfate. Now, you might notice we've got 2 of these over here, only 1 over here, but we also have 2 of these. So that means 2 and 2, 1 and 1. Why not just double this? Boom. 2, 2, 2, 2, 1, 1. This guy, we'll count him as 1, you, 1. Perfect. Balanced. And this is nice because this is a 1, 1, 2, 1. We don't really need to worry about this side, but you always balance your equation before you're solving something. So we know the volume of this is 45.2 milliliters. And then we know this is 0.222 grams, which is its mass. So we'll do little m. I'll use MOL for moles so we don't get those two confused. So, and we want to find this thing's number of moles. Now remember, our moles, oh goodness, that's really big. Moles are the number of grams divided by our molar mass. So our MOLM, our molar mass. And pull up this trusty little website, PubChem. I recommend this 100%. Best website. It has actually carried me through this class. Alrighty, this is the website that I'm talking about, by the way. Also, this was the other instance of you not being able to see my screen The website's called PubChem. As you can see, it is for chemistry. It has all sorts of stuff. It's got a periodic table, has molar masses, atomic weights, atomic numbers, literally anything. You can group them by all sorts of stuff. And then we were looking for sodium sulfate. So like it's got that right here. So boom, molar mass. That's how I got that so quickly. Sodium sulfate. It's got names, common names, chemical formulas, structures. I mean, just about anything you could ever want on here. PubChem. There's the URL if you want it. It's very nice. So, where's my window? There it is. So we're gonna, oh goodness, why is it so large? Shrink it. All right, so what are we trying to find? Sodium. Is that sodium sulfate? Yeah. So if we look up sodium sulfate, and then, yeah, that looks right. So click on you. And what is your molar mass? It should say, there you are, 142.04. Which, so if we write down molar mass, so grams. So now we'll start working out this problem. We'll go our grams, 142.04 grams per mole. So we have 0.22, so we'll take U. So we have 0.222 grams. And then divide it by this, which is 142.04. If we pull up our calculator, 0.222 divided by 142.04, we should get that incredibly small number, which we can round to, we'll say 3 sig figs because there's 3 right there. So, equals 0.00156 moles. So now we've got this thing's moles. So this, we can go ahead and erase you. And now we know that, oh, come on, click on the, oh, I was clicking, there we go. 0.00156 moles. So now, since if we look back up here, 1 to 1, these have the same number of moles. So that means this guy's moles also equals that number. So what color do we do now? Yeah, we'll do green. So now, to solve for the molarity, all we got to do is take our formula over here. So we go moles, which is what we're trying, or molarity, which is what we're trying to find, which is moles per liter. So moles 0.00156 divided by, now remember, milliliters to liters, multiply by 1,000, or in this case, divide by 1,000 since we're going the other way. 45.2 divided by 1,000 divided by 0.0452, and then M equals 0.00156 divided by 0.0452. We end up getting our molarity of 0.0346 moles per liter. That's our final answer. And honestly, that's the hardest test, or not the hardest test. That's the hardest question in the packet, in my opinion. So if you think you've got this down, you're gonna nail the test. But